Okay, students, we're here with dilations phase 2, and we'll actually get into another step of dilations called similarity towards the end, really set us up for some success tomorrow. But nonetheless, let's just dive in. This is kind of a repeat of what we did yesterday, but repetition builds skills, refresh our memory, and just get really good at things. All right, so we're going to determine the scale factor of the following similar figures and class each one as a reduction or enlargement. So before we even do stuff like we can analyze, I'm just looking at two things, A and B, A prime and B prime. All right, we can immediately tell it's a reduction. Now, what's the scale factor? I'm not sure, but I know it has to be less than 1. All right, because that's what reductions are less than 1. All right, now focusing on some things like, let's look at A, that's at negative 6, negative 9, A prime is at negative 2, negative 3. So like what am I multiplying by? All right, how do I get negative 6 to be negative 2, negative 9 to be negative 3? Well, you can think about dividing by 3 or multiplying by 1/3. All right, that's what I'm doing. It's getting smaller by a factor of 1/3. All right, so that's how you determine. All right, and quickly, like another way you can even think about it, you could pick any side, but like that length right there is 4, from D prime to C prime is 4, D to C is 12. How do you make 12 into 4? Well, you multiply by 1/3. All right. Now, same thing, like just looking at the triangles in number 3, which is the next one. We go out of order, we skip 2. All right, A prime, B prime, C prime is bigger. I can tell by just looking at it, so I know it's an enlargement. Now I know my scale factor has to be bigger than 1 because that's the rules for an enlargement. And I'm going to just I like to look at the coordinates. That's what I like to do. Maybe you like to actually count a length, but nonetheless, all right. Well, 3, 2, and this is actually kind of a good point of what I was just talking about. And now this is 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. All right. So then this is at 7, 6. All right. Oh, I see what's going on here. So sometimes this is a good thing to point out. Notice how we're not. This one is we're not dilating, so this one's a minor trick problem. Notice how this is the center of the dilations. So notice how it doesn't really make sense. So most of the time, it'll be like this on tests and quizzes where we can just count the coordinates. In this case right here, if it just doesn't really work, count the lengths. All right, this is a length of 2. This is a length of 1, 2, 3, 4. All right, so this was a minor trick problem. This dilation, I said this earlier in yesterday, dilations. This dilation not from origin. So I guess really only looking at the coordinates only work when we're dilating at the origin. But again, if we converge these lines back, we can see we're not hitting the origin. So the center of dilation is not there. This is kind of a challenge problem because you can't do it the typical way. You got to count it. But nonetheless, we just see we're multiplying by 2. The scale factor is 2. All right, and then here we got one not in the coordinate plane. All right, what do we got here? Let's look. Well, I can see from like C to C prime, I can tell I'm getting smaller, so it's a reduction. And then given this stuff, like you remember, I went final over original. All right, so final is going to be C to C prime over C to P. And looking at this right here, it's going to be 3.5 over 7. I'm using this right here. It tells me C prime to P was 3.5, C to P was 7, also known as 1/2 after I reduce. All right, so some similar stuff we did yesterday. Number 3 was slightly tricky, but not too bad. I think you guys still would have been able to overcome. Now we're going to apply the following rules to the image below. So we're going to get some quirky numbers, but it's okay to deal with some quirkiness. All right, not everything comes out to nice, slick whole numbers, but we're going to enlarge by a scale factor of 1.5, and we're going to do it as origin as the center of dilation. All right, so really, you can even just like kind of write some side notes. Let's do it over here. Like A is 3, 5. We'll multiply both points by 1/2, 1 and a half, not 1/2, 1 and a half, or 3.5. I mean, I know it's a little quirky, so maybe you want to get your calculator ready, but A prime would be 4.5, 5 would be 7.5. All right, so that's what I'm going to do. So then A is at 4.5, so 1, 2, 3, 4, 4.5. Then at 7.5, so 6, 7, boom. That's where A prime is. And then same thing, B. I'm not going to rewrite B prime, or B, excuse me, but I'll write out B prime. So that's going to give me 6, 3. After calculations, again, I'm just taking 4 and 2 and multiplying by 1.5. And again, quirky numbers. It's okay to deal with quirky numbers. It's okay to struggle a little bit. But if that's the case, you have to be really good at using a calculator. All right, so that's going to be at 6, 3. Use the tools we have. And then I'm going to take C, which is 1, 1, multiply by 1.5. It just gives me 1.5, 1.5. All right. C prime. And then let's connect this and make this look pretty. Bada bing, bada boom. And like I was kind of mentioning before, what's going to be expected out of you, just do stuff centered at the origin, where that's where we're stretching from, and how all the lines converge back there. All right. But you don't have to draw those electric green lines that I just drew. I like to do those just for fun. All right. So that was an enlargement. We got bigger. Now we have 1/3, so it's going to get smaller. And again, like 7, like looking right here, we're going to have to do 7 times 1/3. That's weird, all right? That's a weird thing to do. So use a calculator. You're going to get some quirky decimals. It's okay. And in fact, this time, I'm just going to rewrite all my things out. D is -3.7. So D prime will be, I'm just going to, well, -1. -3 divided by 3 is -1. That's easy. But what's 7 divided by 3? All right, oh, it's 2.33333, so I'm just going to do 2.3. I'm just going to estimate a little bit because we're doing it in a coordinate plane. We're not going to necessarily be able to be perfectly on each one. E prime is going to be -0.3, or -1/3, 1. Thing I like about Notability is I can reorganize my work easy. EF. F is at -7.5. So using a calculator, I can see -7 divided by 3 is about -2.3. And then let's see, 5 divided by 3 will come out to about 1.7. Okay, some quirky numbers. It's good to have to deal with decimals every now and then. I mean, look at money. Money uses decimals. You guys have to be used to using decimals. And that's going to give me -1.7. comma -0.3. Quirky, but sometimes we just got to deal with it. So let's carefully plot each point, -1, 2.3. I mean, I'm kind of guesstimating a little bit. That's where D prime will land. E is at -0.31, so boom, kind of there. Just doing my best. That's where E prime is. G is at -1.7. Then -0.3, so G is kind of right there. G prime, and then F is at -2.3, 1.7. So kind of right like that, yeah. And let's make this dandelion yellow. Let's make it look pretty. Beautiful square right here. All right, and then I could draw the lines to converge back, but I don't feel like it. All right, so that's that. Let's just knock out some more problems. Let's keep rolling. So use the scale factor to determine the new dimensions of a figure. A quadrilateral with side measures 12, 16, 20, and 24 with a scale factor of 3/2. Will a dilated figure be a reduction or an enlargement? All right. So it's an enlargement because we have a scale factor of 3/2. All right, and the given, so original, I'm going to write ORIG for original, are 12, 16, 20, 24. And again, what are the final lengths? Well, again, you might struggle with doing calculations like this, or it might be quite easy for you, but nonetheless, like here's how you do it. You just do 12 times 3. That's going to spit out 36. Then you're going to divide by 2, which gives you 18. So just do each part of the computation at once. I did, because it's 3/2, so I took 12 multiplied by 3. Then I divided by 2. All right, and that's how I determined 18. Or you can just plug it into a calculator. All right, 16 times 3 divided by 2, 24, 30, and then 36, I believe. Yep. All right. So I did some calculations off screen using a calculator, but nonetheless, like, know how to do this stuff. If you don't know how to do this stuff, use a calculator. We have your phone's a calculator, your iPad has calculators, there's calculators on the internet. You might actually have a calculator. Know how to use your resources. All right, the dilation image of a triangle ABC with points -2, -2, 1, -1, 0, 2, with center of dilation at the origin and a scale factor of 2. The coordinates of A prime, now it's just asking for A prime, so let's focus on that. A is -2, -2. Scale factor is 2. So you're just going to multiply each point by 2. So A prime will be -4, -4. All right. Ooh, I like number 3. Number 3 is a great problem. Triangle ABC has been enlarged by a scale factor of 3 to triangle A prime, B prime, C prime. What is AB when A prime, B prime is 15? So there's a couple ways to think about it. Some people might immediately say 5, which is the correct answer. All right. But to explain my thoughts, remember the scale factor is calculated by doing the final over the original. And in this case, it's A prime, B prime over AB. All right. So that's how, in general, you calculate the scale factor. In this particular case, the scale factor is 3. A prime, B prime is 15. Well, what's AB? All right. And I'm going to rewrite AB to simplify things as just X. All right. Now, how do you go about solving this? I mean, you can use some common sense, but this is kind of a build-up to what we'll be doing moving forward. Is if I write 3 over 1, we're going to use an incredibly famous technique to solve this called cross multiplication. All right, then we get 3x equals 15. Then divide both sides by 3, and x equals 5. All right. This is kind of a similar problem, it's different, but after a dilation of an image about the origin, a point initially, so it's initially, we'll call this A, be real creative and just call this A, 3.55. Now A prime is at 1420. All right, what are the coordinates of P of a point at 0.57 after the image undergoes the same dilation? So what did I do? What's the scale factor to go from here to here? Well, the scale factor, it's easy just to look at 5 to 20. What do I multiply by? 4. All right, and 3.5 times 4 gives me 14. All right, so the scale factor is 4. So we'll call this point B is at 0.57 using a scale factor of 4. That's going to force B prime. Well, what's 0.5 times 4? 2. What's 7 times 4? 28. All right, and that's the answer right there. All right. So that's it for scale factors and stuff like that. We're going to talk about some ratios and some similarity stuff moving forward.